right, so today I wanted to present on how to get started with PySpark. We're not going to get too deep into Spark architecture or kind of Spark by itself. The main objective for this presentation is to kind of, if you're working on a project, it could be a data analytics or data science project, and you have you're working with big data. By big data, I mean data that wouldn't fit into one machine, and you're struggling with kind of memory optimization and how to trying to run different operations. That way you can use PySpark instead of Pandas or whatever you're using, and that would kind of help you to save memory and save time running all those tasks. But yeah, I'll start a little bit with Apache Spark. Apache Spark is an open source distributed processing system used for big data workloads. It utilizes memory caching and optimized query execution for fast analytics queries. So I'll kind of explain more what I mean by that and later. And then it provides development APIs in Java, Scala, Python, and R, and supports code reuse across multiple workloads. So it's batch processing, interactive queries, real-time analytics, machine learning, and graph processing. In this session, we'll particularly focus on Python API, which is PySpark. And this is kind of the overview of what we can do with PySpark. So there's Spark SQL, Spark Streaming, Spark Machine Learning, and Spark GraphX. So we'll only focus on Spark SQL and Spark Machine Learning in this session. Spark Streaming primarily used for real-time data processing. I feel like it's more, it would be more relatable for like big companies who are kind of getting real-time data, and Spark is kind of used to also utilize memory and kind of make that process a bit more faster to run. And then Spark GraphX it's like a library that we can do different GraphX analysis. So it could be network analysis, it could be like page rank analysis. So it's mostly to kind of visualize the way, like visualize and represent data using graphs. Yeah, so that's another interesting library, but we won't be able to focus on this today. We only have 1 hour. So a little bit about Spark architecture, like what makes Spark architecture, like how does it utilize memory and why is it faster than, like, for example, using Python or something like that, or Pandas. So usually when different tasks are running, they usually kind of run sequentially. So it's like step by step, but in Spark specifically, it's allows us compute in parallel instead of in sequential order. So it kind of divides one big task into multiple smaller tasks, and all those smaller tasks are run by itself. They run by itself parallelly, and that way we can kind of run all those different tasks in a separate different machines. So it could be machines or servers. Yeah. So to get kind of started. The way PySpark operates and kind of uses Spark is we first of all create this cluster. We initialize a Spark session, and then and this is kind of the tool how PySpark interact with Spark. So each user of the cluster has its own Spark session that will allow us use the cluster in isolation. So by cluster, so this is kind of one cluster, one session, and all the sessions are communicating with the main node, and then and so each cluster has one main node, and then that main node assigns computations to worker nodes. So there are multiple worker nodes depending on the size of the operation you're running. There will be more than 2 nodes. So in this example, it's just 2 worker nodes, and the cluster manager has this, it manages the cluster, communicates with worker nodes and communicates with main nodes, and also the main node allocates computing power to worker nodes, and cluster manager is responsible for that. And then each worker node runs tasks in parallel with other worker nodes and has its own cache for storing results. So that's kind of like how I explained it here. So it kind of divides one big node into worker nodes, and they all run at the same time, but in isolation. So what is PySpark? So you probably understand by now that PySpark is a Python API for working with Spark. I'm assuming a lot of you have understanding of how Python works. So it's kind of easy to use, and PySpark is a bit more, I guess, a more accessible way to use Spark. And yeah, usually we define the amount of data that suits PySpark that would not fit into single machine storage. And then there are different important related concepts that kind of you probably heard when people talk about Spark. There is distributed computing. So when you distribute a task into several small tasks and run all of them at the same time. So that's called distributed computing. And PySpark allows you to do on multiple machines, but it can also be done on a single machine with several threads or servers. And then cluster, which is essentially a session, is a network machine that can take on task from a user, interact with one another, and return results. And then RDD, resilient distributed data sets, something that people don't usually use it. This is kind of was the regional data storage that Apache Spark used, but right now we're kind of using data sets. And at the core are these immutable distributed collection of elements in your data, partitioned across nodes in your cluster, that can also kind of operate in parallel with a lower level API. So yeah, like essentially Python plus Spark would be PySpark. Yeah, there is also, so I guess we'll kind of focus on PySpark SQL. So PySpark SQL is not a database. It's not a SQL database. It's just a library that allows us to apply SQL-like analysis on a huge amount of data, structured or semi-structured data. So for people who kind of like the way SQL works, like SQL-like operations, PySpark SQL is a good kind of option to do data analysis and work with data. And then MLlib, which is a machine learning library using PySpark, and this library uses data parallelism technique and store and work with data. It's quite easy to use, supports many machine learning algorithms. It also supports different NLP techniques. It doesn't support a lot of deep learning algorithms yet, but I think there's the library is constantly evolving, and there are multiple updates every day you can see, and I think soon enough we'll probably see all the kind of popular deep learning algorithms in MLlib as well. Yeah, and then so GraphFrame is a purpose graph processing library, provides a set of APIs for performing graph analysis efficiently. It also uses PySpark core and PySpark SQL. And it also optimized for fast distributed computing. So I guess advantages of using PySpark, yeah, we can use Python. It's very easy to learn and implement. It also provides a simple and comprehensive API. We can easily install it and use it. And also, like with Python, the reliability of code maintenance and familiarity is far better. And it also has various options for data visualization, specifically with graph frames. And yeah, and like for people who knows pandas, it's very easy to kind of start using PySpark because it's very, very similar. So today I want us to kind of get started. You don't have to, you can also do it on your own, or you can follow me right now. So if you want to follow me, the first thing you have to do is to clone this repository. I'm assuming everyone has the GitHub account, and we just need to clone GitHub Brown CCV PySpark. Yeah. If anyone's experiencing any difficulties, please let me know. I can also slow down. And if you're done, you can also give me a sign that you're done so I can continue on next steps. All right, are we good? Good to go? All right, so I guess people have different preferences. I kind of thought of maybe using Anaconda, but if someone doesn't like to use Anaconda, we can just use Brew and Peep. So it's up to you guys. So I can go over kind of how to install that using Anaconda, and I can also go over how to use Brew and Pip install. So if you don't have Anaconda, you can install Anaconda. You can also use it Brew, or you can use this link and kind of install it directly from the website. But I think that might take a long time to install Anaconda. So maybe you can do it on your own time. We can kind of go through. Yeah, so also if you don't have a notebook, Jupyter Notebook. So we'll be working with Jupyter Notebook today, and you need to have a Jupyter Notebook for that. So if you don't want to use Anaconda, you can just install, first of all, you need to have Java, and you need to install Python. So you need to run this in your terminal. So you first install Java, and then you install PySpark. You can also install Java using Conda, but I've noticed there are some issues with that. So I think using Brew is a better way to do that. Yeah. All right. So once you clone the repository, so once you clone the repository, there will be an environment YAML file. So if you're using Anaconda, you can create environments with that YAML file. Right, so the environment is installed. Now we can activate it. And then I like to use IPyKernel to add that environment into your Jupyter Notebook. So because IPyKernel was already in the YAML file, so I'll just kind of show what's in the file. So there's PySpark, IPyKernel, pandas, and matplotlib. So yeah, so in order to add the environment into your Jupyter Notebook, you need to copy this line and then. Okay, so you see installed kernel. So this environment should appear in your Jupyter Notebook when you're running. So once it's there, we can run a Jupyter Notebook. And then, so this is the repository. There's a folder called notebooks. And this is the notebook we'll be working with today. You can see the PySpark tutorial is there. So the data used in this project is from Kaggle competition, very like overused, I guess, data set. A lot of you are probably familiar with it. It's housing values in the suburbs of Boston. And since we're not kind of focusing on the machine learning part of this project, I'm just kind of giving you a tutorial how to use it. You can use this notebook as a kind of notebook to like kind of have this if you're using PySpark on your own with different data sets, you can kind of look up this notebook and just kind of use those operations on your data. This is kind of mainly for practice. So I'm assuming you're using Anaconda environment. If not, you can install all your packages here or in terminal separately without using Anaconda. You can just do pip install. So first thing is import necessary packages. So we'll be working with PySpark, PySpark SQL. There's different MLlib. So we'll first start with just simple linear regression. And then there's vector assembler that allows us to kind of do the train test split with the data. And I just imported warnings, so we don't need to focus on them. So this is kind of the session. This is how we create a cluster in Spark. We initiate a session and then okay, I'm having some issues with Java. I'm gonna change instead of Conda, I'm just gonna use pip. Okay, so yeah, so I don't know if anyone's having problems with Conda. It helped me to just use pip install instead of Conda. And then so here we go, we initialize the cluster. We can name it however we want to name it, and then that's kind of a way to interact with Spark. And then we can run Spark and kind of see the version of Spark. There's even UI to kind of see the memory utilization and kind of the tasks you're working and what's failed and what's not failed. There's storage, environment. There's even a SQL data frame. You can kind of look into your data, which is useful. Yeah, so first thing is we'll read CSV. So the pandas is actually very similar. In Spark, you just do this operation, and then you can do infer schema. Schema is kind of integrated in the data. You want to use the schema that is in the CSV file. You do infer schema equals true. And then header, if you want to include the columns names in your data set, you also set it to true. And you can also print the schema. So you can see all our columns. So here, this is kind of the features and features of the data. So there's per capita, crime rate by town, proportion, so all those things. And I guess all of them will be our features. And then this is our target median value of owner occupied homes in 1000s. So yeah, this is the target variable, and the rest are features of the model. Yeah, so we can kind of see the data types of each column. So I guess in pandas, double means float. So in Spark, they use double. We can look at that, and then we can see the number of rows in the data. It's a very small data set. This is just as an example. We can also look into summary, which is kind of alternative to data.info in pandas. Or we can kind of look into how many rows in each column. So 506, 106. And we can do the head. Instead of head, we use show. And we specify how many rows we want to see. And then we can also just do data types by itself to see what are the data types. So in our case, there are no NA values, but this is just an example how to drop any NA values. We can do drop just on all the columns, and we can do NA drop on specific thresholds, at least 2 values that are not NA. And then here we can do it based on the subset, based on the target variable. So this, I'm checking how many rows. So we didn't really, yeah. Mm-hmm. Mm-hmm. Oh, so I didn't use Conda. You can change the kernel. So instead of using the PySpark tutorial, you can just use pip, and you can just set the kernel to Python 3, and then install PySpark just by running this in your notebook. Did you download the Java? And make sure the Java is 11. So if you go here, so you could try, yeah, so you can copy this and run in your terminal. So this is Java related issues. Yeah. 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 So it's Java in PySpark. Let me know if it's working. Right. I will continue for now, but feel free to interrupt me. I can also help you after the session. Yeah. So when we compare, so you probably noticed that PySpark is very similar to Pandas data frame, but under the hood, they're very different. PySpark data frame needs to support distributed computations. And then as we move forward, we'll see more features that are not represented in Pandas data frame. So this is just example how we can perform descriptive analysis. We can group the data by age, similar what we can do in Pandas. And then we can also sort values. And then we can also do different plots. So here we can kind of see correlation between different features. Since we'll be creating models. The first model is linear regression. We want to make sure that correlation, there's no between dependent variables and target variable. So we can't really, it's a big plot. So I think it's better just to kind of plot, to see the values themselves. Overall, I don't see a high positive or negative correlation between features. So I'm just gonna not remove any features in my data set and kind of keep them all. So here we're kind of moving into the SQL queries in PySpark. So for people who likes to kind of use SQL and likes the operations of SQL, we can convert this data into temporary view in SQL, and then we can kind of query different data from the SQL data. Yeah, we can also perform any other operations that are performable in SQL, in Spark SQL. We can also do select expression. We want to filter by different values. And so, yeah, we're going to keep all the variables for now. And we can start prepping data for machine learning. So we need, in reality, I guess when we're kind of trying to fit data into a model, we kind of have to separate targets and all the features. And in that way, we kind of create two separate columns. One is just all the features in one column, and then another is a target variable. So we use this package called vector assembler that is also part of PySpark ML. And then we include all the features we want to use in the model, and then transform them into kind of this data. So it has features and the target columns. And now the next thing is we can use this to kind of do the random split. So we're doing 70 to 30%. We can also add, if you want to use validation set, we can also add another here and then kind of split them by test train and validation. There is also tools to use cross validation. It's not included in this notebook, but in the future, if you're trying to do any kind of modeling, you can use cross validation in PySpark as well. And this is kind of the first simple model. We're going to build a linear regression model. You can use the same parameters that you can use in sklearn, but in this way, you can use PySpark. And then we can also look into coefficients. Oh, here we have to run this first. So we can look at our coefficients in the linear regression, and then this is our intercept. And then we can also do a summary. So we can kind of see the results of the models, root mean squared error and R squared. This is just based on the training summary. So we want to do, we want to kind of look into summary in the test set. So here we apply the model and test set to kind of evaluate the model. So R squared and test set is 65. And root mean square, 4.9. I'm assuming if anyone wants, kind of R squared represents kind of how explainable, how much the model explains the data set by using those features that I provided. And RMC is kind of, it's a one-way evaluation because we'll be creating different models as well. And we can kind of compare them, which model is better, and kind of make decisions on the primary model. So here we kind of, next model is just a decision tree regression. So similar way we applied linear regression. This way we're using decision tree. We provide features, provide label. This is our train set. This is our test set. And then we kind of look into root mean square. So it's lower, so it means our model is improving. And then we can also do a feature importance. For each feature. And then the last model, just to give an example, is a gradient boosted tree regression. Yeah, so the root mean square decreased just a bit, but didn't make a big difference. So yeah, this is kind of the summary on how to get started with PySpark and kind of implement them in your projects. Yeah, if anyone's experiencing any errors, I'm happy we have some time right now, and I can kind of go into details. And if you have any questions, also, I'm happy to answer. Also, were you able to get it running? Okay. I can look it up if you. Yeah. Oh, yeah. Okay.
Oh, that's not it.
Did you get a burrito?
Yeah.
Oh,
I got a lead it too.
sure. It's huge.
Nothing else. I mean, I guess I could lose them too, or choosing to keep them. You know what? My dentures would fall out.
What time do you get? I'm leaving by the airport at 4.
Hey, look, you're going to the airport in Florida party? What time is the flight? Oh, that's your night flight. 2 hours. Oh, you're flying then.
Oh, and then my passport.
But it's not a connecting flight or?
Well, not necessarily, but,
Yeah, your friends in LA. LA, it's not like Hollywood.
Yeah.
Hollywood and all that. Wow. You know,
Just like but you're, I think, yeah. So, yeah. Our adopted theory is here, we're gonna be students. What is the? Yeah, yeah, graph. So then you're, once like. Yeah.
Maybe I'll bring it up there on I can sleep it right. It's like I want to actually put just keep like.
So like, because I was looking at the example that we had for the. I was wondering, like, what if you hear it's.
What kind of is like a fast. Water. Okay. like one connection. Same route. That's so how does anything that can like scale across budget, so like so what the funded NSD, or like JBOD is still the funded right? 12 terabyte disk is like one big box, like coordinating all of that. That's the Java all of this. But on our local distribution, it's coming one disk to manage. So like you know what Apple uses its own DFS. Yeah. It's more Microsoft, background okay. No, it reminded me of yeah. I can tell you're getting a little bit of patient, like, you know, PySpark stuff was on there. I remember making the data science cloud. Also, we had to run with this, getting us things work for like set the Java whole. Yeah, me too. What's next? What's that on? Singularity containers, that's the problem that you mentioned.
Oh, yeah.
Especially how other people